All right, I'm going to try recording this once again. It would not record my voices after I was finished for some reason. So this is take two, lesson 8.5, polygons and coordinate planes. So taking what we have been doing and applying it all together. We're going to take a short commercial break brought to you by Mrs. Bloss. So Mrs. Bloss was working with your group yesterday and had a great analogy that I want to share with you. I'm going to connect it to Disney movies because I love Disney movies. But she was talking about ants and grasshoppers. And as you can see in Bug's Life, at the very beginning, you see the ants all working together, following a specific step, a specific routine, collecting different things, doing it in a different way. Notice they each have different types of items, but they're all following the same steps in front of them. And then when a leaf falls in front of them, they get confused. They don't know what's going on. And the leader ant comes out and said, "Hey, don't worry, I've got this." That's what we do as teachers. When we see that you're struggling or you ask a question, you're not really sure, we're here to help you and help you work around the leaf so you can continue on following the pattern that is set up. But some of you want to be grasshoppers, and grasshoppers are sporadic. They don't have a set system, they don't have a set routine, and they're often lost and confused. Right? They just jump from here to there, some jump, some run, and you don't ever know where they're going to land. They are not systematic. So the whole lesson is, other than Disney makes really fun movies and great life lesson movies, stop being grasshoppers. Follow the path that is set in front of you. I will always do my best to take as much time as I need to teach math in the best possible way that I know how, so everyone will be able to understand it. You just have to be willing to learn the process. This lesson is all about steps and processes. And there are some of these questions that are going to take a lot of steps that we have to know and the process that we have to get through. The goal of this lesson is to be able to graph the vertices of a polygon and draw the shape. Now, we have to know what that means, right? So, a vertices. So, this was taught, I know, in fifth grade, maybe in fourth grade, but just to review it, a vertex, which is singular for vertices, is where two lines or two edges come together and make a point on a shape. I'm going to jump ahead a little bit to try to give you a visual of what that means. All right, so when we get into three-dimensional shapes, we have three labels that we need to understand, right? So when we talk about three-dimensional shapes, we have edges, faces, and the vertex or the vertices. The way I teach it, so hopefully you'll remember, and we will go back through this later on, is that edges, if I think about edges starting with a capital E is made with all straight lines. So the straight lines in the shape are edges. The faces are simply flat, and faces and flat go together because they both start with an F. When it comes to a vertices or a vertex, they have a point. And what I mean is the first letter, the V, capital letter or lowercase, they always have a point at the bottom. So we're talking about two lines coming together to make a point. That is a vertex. If I have more than one point, then I have a vertices. So what we're being told we're going to be able to do in this lesson is to take the vertices of a polygon, straight-sided shapes that are closed in, and draw it. Once we're able to draw it on a coordinate plane, then we're going to be able to find two measurements. Right? So we're going to be able to plot it, and then we're going to find the area, and we're going to find the perimeter. So when we get into this, it says you already know how to graph points on a coordinate plane. You can also graph polygons on a coordinate plane. And we have done that multiple times. Remember shapes like this? You know how to graph points and shapes on a coordinate plane. So that's not difficult. But I'm going to always review how we do it. I know that in the book it says, hey, you're going to see this image, and you go to the Reveal website and you can look at the tutorial video and all that, and they give you the shape. We're going to walk through the shape because, once again, we need to review how we run and jump so it's always fresh in our mind, because you got to know that at the very beginning next year of 7th grade. So I see that I have 4 points, and they tell me that the label for each of the points is in front of it. So I have point A, B, C, and D. So when I start with point A, easiest one. It says it's ordered pair, once again, in parentheses, separated by comma. First number is my X, tells me to run. Second is my Y, tells me to jump. Is 0, 0. I'm not doing either. So I simply put a point, and it tells me to label it A. Point B then tells me 3, 4. So the ordered pair of 3, 4 tells me to run forward 3. And then once I run forward 3, I jump up to the 4. Once I get to the 4, I'm going to put my point. It tells me to label it B. My third one is C. It says to run 5, jump 4. The ordered pair of 5, 4 says to run forward to the 5, jump up to the 4, put a point. I label that C. And then my last one is D, 7, 0. So I'm going to run forward to the 7. 0 on the Y tells me just to leave it there. So I'm going to put my point and label it D. Now we have these labeled because we're making a polygon. And once again, a polygon is straight sides that is closed in. So I'm going to connect them in alphabetical order. A goes to B, B goes to C, and C goes to D. Since it's a polygon, it has to be closed in. I always take my last point and connect it directly back to my first point. So I close in my shape. Now it is a polygon. That is a four-sided polygon where it has one set of parallel sides. That means that is a trapezoid. Right? Should be pretty easy plotting these. Not a difficult lesson. It says then, if I can do that, then I can not only plot to find the perimeter, but I can also use some specific information. Now, I'm going to ask you to mark these in your book, and if you have two different colors, that would be great because there are two different steps. But I'm going to demonstrate this for you also as we move ahead. Right? But if I want to find my dimensions, now, number one, dimensions, that just simply means measurements. So don't let the word dimensions confuse you. It just means what measurements do I need to find my perimeter. But it tells me that if I have my ordered pairs, if I know where my points belong, then I can find the distance between 2 points that have the same x coordinates if I subtract their y's. So if the x's are the same, that means the y's are different, and all I have to do is subtract them, and I can find that distance. In the opposite, it says that if I find a distance between 2 points that have the same y coordinates, then I can subtract the x's. Now, I know that that sounds a little confusing, but I'm going to once again demonstrate this to you so we can know how to find the perimeter. Once again, perimeter means the distance all the way around. Area is filling it up, right? So that's where we use 8.1, 8.2, and 8.3 to fill up our shapes. So we do our 3 formulas. So what that's telling me is if I have these and I go and I plot my shape on the coordinate plane, it says that it's going to be a rectangle. And all of these are positive for right now. So all I have to do is run forward and then jump up. Then I'm going to look at A, and that tells me to run forward to 1 and jump up to 5. I put a point, and then I label it A. Once again, we need those labels so we know how to connect them. Now this tells me it's a rectangle, so it should have things that are lined up as I'm plotting them. B tells me it's 7, 5, so I'm going to run forward to the 7 and jump up to the 5. Notice how B is straight across from A. Then I'm going to plot C. C says I'm going to go forward 7 again, but this time I'm only going to jump up to 2. I put my point and label it C. Notice how C is directly below B. So if I didn't have my coordinates for D, I should be able to locate that pretty easily by going straight down from A and straight across from C. But it goes ahead and gives me the coordinates anyway. It tells me to go forward to the 1 and jump up to the 2. And hopefully that's where we would have intersected if we didn't have the D. But once again, I have a rectangle. And a rectangle we know has opposite sides are equal. So I'm going to close in my shapes going from A to B, B to C, C to D, and then closing it in because it's a polygon, D to A. Then I'm going to count my units. I want to count the boxes. Now, don't count the lines because usually what happens is people start right at that point where D is and they count that first line before they go anywhere as 1. Just count the boxes as you're going across and you won't mess up. Okay, so as I'm counting the boxes, I see 1, 2, 3, 4, 5, 6. I see that I have 6. Now it's a rectangle, so that means opposite sides are equal. So if I found the measurement for the bottom, I also found the measurement for the top. If I want to find the right-hand side, then I count the units or the boxes going up, and I see that there are 3. So if I found the measurement for the right-hand side, once again, because it's a rectangle, then I know the measurements for the left-hand side. The perimeter means I'm going to find the distance all the way around. So I have to add all of those together. 6 and 6 is 12, plus 3 is 15, plus 3 is 18. So I see that I have 18 units. If they don't give me a unit of measurement like inches, feet, miles, yards, then I use the term units because it can represent anything, but I still need a label. Now, what if I don't have a coordinate plane to graph those on? Now we're going to look at what the highlighted portion means. So I want to find two ordered pairs that go together where either the x's are the same or the y's are the same. So I'm going to look at point A and point D because I see that the x's are both 1. I want to look at the one that's different and put the biggest number on top. So if I have 1, 5, and 1, 2, and the ones are the same, then I'm going to put the 5 on top. And what that's telling me is what we highlighted or marked in our book. If the x is the same, then all I have to do is subtract the y's to find the measurement of that side. Well, 5 minus 2 is 3. Well, once again, it's a rectangle. And if it's a rectangle, I know that opposite sides are equal, so I have to have 2 of those. Right? So if it's a 4-sided shape with opposite sides that are equal, I multiply it by 2. And 3 times 2 is 6. All right, so I need to pair up another one, but this time I want to find the one that has the y's that are same. And I see that I have a 5 in B and A. So I'm going to pair up 7, 5 and 1, 5 and put the 7, 5, the B on top, because 7's bigger than 1. So pairing those up, I can now subtract the x-axis because the y is the same. And 7 minus 1 is 6. Well, once again, as a rectangle, I have to have 2 of those, and 6 times 2 is 12. When I add those together, what do I get? Well, 6 plus 12 is 18 units. Remember what we got when we actually plotted it and counted all of those boxes? We had 6 plus 6 plus 3 plus 3. That still gives me 18 units, right? I personally feel like this is easier, and I will work through several of these so you can see how it's done, right? But if you need to count the units to find your perimeter and find your measurements, then please do. It's okay, because both ways are correct. All right, so this one tells me I'm going to find the distance from the entrance gates to the monkeys, and then from monkeys to the gorillas, and then I want to find the distance all the way around the zoo. So it always helps when you start by reading the directions, because I'll be honest, when I first made my PowerPoint, I went from the entrance all the way around to monkeys and then backed up to the apes, and I was really confused, and then I reread the directions, and that's what happens when I skim as well. Right? So don't skim, read what it says. It says we're going to count the units, which means we're going to count the boxes. Start at the entrance, easy enough. How many units do you need to travel along the y-axis? That's the point that I missed the first time I did my slide. Right? So along the y-axis to reach the monkeys. Once again, monkeys are not apes, apes are not monkeys. So I'm looking at the monkeys, which are straight up above. Going along the y-axis means I'm going to go from 0, 0, and I'm going to go straight up. So if I count all of those boxes, I end up with 10. I would know that because it shows me that it's on the line 10, right? But that's 10 units. Then it says, well, how many units do you need to travel along the x-axis? So now I'm going to go forward from the monkeys to the gorillas. So if I count each of those boxes, 1, 2, 3, 4, 5, I have 7 units. Right? But now it says, well, what if I want to find the perimeter of the entire thing? Well, then I need to count all of those boxes, right? I know I have 10 and 7. Well, going from the gorillas down to the elephants, I go from 7 down, or from 10 down to 7, and that's 3. And then I'm going to go from 7 to 11, and that's 4. And then I go from 7 down to 3, and that's another 4. And then I go from 11 back to 7, and that's 4. And then from 3 down to 0 is 3. And then from 7 all the way back to the entrance gate is 0, so that's got to be 7. So if I add all of those together, then what I find is that the perimeter of this particular zoo, according to this map, is 42 units. So we know how, I mean, it could be 42 miles as far as we know, be a really big zoo, right? But we don't know. So therefore, we just use the unit measurement instead of trying to figure out if it's yards, feet, miles, or anything else. Okay? So what I'd like you to do is I would like you to do this. I'm going to then show you what I feel like is a shorter way of doing it than counting units. But if you understood the looking at common axes and subtracting, then do that, or just count the units. But go ahead and find the answer on what is the perimeter of this particular park, and then pause the video and check your answer once you have it. All right, so hopefully you have an answer. And if you counted cube by cube, once again, that's okay. There's nothing wrong with that. I'm going to show you what it means by looking at ordered pairs and then subtracting the ones that are different, right? So you could go from the left to the right or from the bottom to the top. And since we went clockwise the first time, I'm going to go clockwise on this one. So when I look at my first two pairings to find the distance all the way around, I have 0, 0, and 0, 9. The x's are the same, so I focus in on the y's. The y's are different, so I'm just simply going to subtract those. 9 minus 0 is simply 9. So I know that measurement has to be 9. If I counted the cubes, I would have 9 cubes. So either way is correct. Then I'm going to go from the left to the right. I see that my 9's are the same, so I focus in on my x's, my 0 and 4. Well, I want to take 4 minus 0, not get negative 4, 0 minus 4, right? So 4 minus 0 is simply 4. Going from the water fountain up to the left bench, then I see my x's are the same, so I focus in on my y's. 9 and 12, so 12 minus 9 is going to give me a measurement of 3. From the left bench to the right bench, I see that my y's are the same, so I focus on my x's. When I take 11 minus 8, I get 7. Then I want to drop down to the tree, and I see that my x's are the same, so I focus in on my y's. 12 minus 9, I get 3 again. Going from the tree to the pond, I see that my y's are the same, but my x's are different. So I focus on my x's. 16 minus 11 gives me 5. Then I go from the pond all the way down to the bottom right-hand corner of the trail. I see that my x's are the same and my y's are different. So I'm going to subtract my y's. 9 minus 0 is going to give me 9. And then I go from the bottom right of the trail all the way back to the entrance of the park, and I see that my y's are both zeros and my x's are different. So I'm just going to take my 16 and 0 and subtract, which gives me 16. Then I can add those all together. And when I add those all together, I can use my handy dandy calculator after I write down my math problem, then I should get 56. Now, the reason I find it easier to do that is counting cubes, sometimes we lose count, right? And therefore we end up with a different number. But either way, if you counted your units or if you did the math, you should still get 56 units, which is the perimeter of this particular park. All right, so let's see what they want us to do with this one. All right, it says a rectangle has vertices for A, B, C, and D. Use the coordinate to find the perimeter of the rectangle. So now they want you to do the process that I just did, right? You can use the cubes if you need to, but if you get into a coordinate plane where it's graphed really far distances apart, especially when we get into the positive and negative, it becomes a little bit more complicated trying to count all of those little cubes. So if I just focus in on the rectangle and I want to find the perimeter, I'm going to pair up the ones that have the same x and opposite y's. Now, especially when it's a rectangle, I am never going to pair up A and C in this example because neither of the x's are the same and neither of the y's are the same. So they will never be paired up. Okay? So I'm going to use, in this particular example, 7, 8, and 7b, which is B and C. For the same measurement, I could have used A and D because the 2's are the same. Either way, I have to take one of those pairings that make up either the left or right. I'm going to do the right-hand side. So I take 7, 8 and 7b because the x's are the same. I put the 8 on top because it's larger, and then I just subtract. And 8 minus 5 gives me 3. Then I want to try to find either the top or bottom. I could use either A and B, or I could use D and C, because they're still going to be the same measurement. I simply choose to use the top two numbers. So I'm going to use A and B. 7 and 8. 8 is the one that's the same. So I look at the 7 and 2. 7's larger than the 2, so I put it on top because I have to subtract those. 7 minus 2 gives me 5. Now, once again, it's a rectangle, so I know opposite sides are equal, so I need 2 of each of these measurements. So I multiply 3 by 2 to get 6, 5 by 2 to get 10, and then I'm adding those together. And 6 plus 10 is 16. 16 units to be precise. Now, if you focus in on that little box and you start counting all of those cubes around the outside of your rectangle, you're going to get that there are 16 cubes in the perimeter of that shape. All right, so I want you to try this process. It says to use a coordinate plane if needed, which means you have to plot them. But keep in mind, when it comes to the standardized test that you have to take at the end of the year, then sometimes they're just going to give you the ordered pairs and ask you to tell me what the perimeter is, right? And therefore, if you don't know how to do this step, this process, then you're going to have to draw on your scrap paper, and that's going to be a lot of drawing. So try this process, right? Once again, be the little ants. Even go back and review it if you need to remember what the process is, but pair them up and see if you can find out what the two measurements are and then find the overall perimeter. Pause, come back when you have an answer. All right, so hopefully you have an answer. And once again, I'm not asking for perfection. I'm not asking you to be the perfect math student. I'm just asking you to try. So hopefully you did not pair up A and C because there's nothing that they have in common. The x's are different, the y's are different, so those cannot be paired up. So I chose for my rectangle to pair up A and B, right? I see that my x's are the same and my y's are different, and I want to put the largest y on top. So when my x's are the same, then I'm going to simply subtract the y's. 9 minus 4 gives me 5. My other pairing that I am choosing is to, once again, I need the y-axis to be the same. So either pairing has to have the same y. So you could have done D and A. I'm choosing to do C and D. No, C and B, excuse me. So I have 8 and 9 and 1 and 9, noticing that my 9's are the same, my y's are the same. That allows me to do the math with the x. When I have 8 minus 1, that gives me 7. Since I have a 5 and a 7, and this is a rectangle, I know I have opposite sides, so there has to be 2 of them that are equal. So I take 5 times 2, which gives me 10. I take 7 times 2, which gives me 14. And then I just add all the measurements together, and I find out that my perimeter would be 24 units. Is that what you got? If not, do you know where you messed up? And if you can't figure out where you messed up and why, please come and ask so I can help you. All right. So when we're doing this particular example, it says identify this polygon, graph the vertices, draw line segments to connect them to form the polygon, and what polygon is formed. So it appears that we're doing something different. Notice we only have 3 points. All right. Shouldn't be difficult because we know how to plot on a coordinate plane. So it tells me that I'm going to run and jump. I'm going to run forward to the 2 and jump up to the 5. I'm going to put my point, and that's going to be point A. For B, it tells me to run forward to the 2, same spot. Now I'm going to jump a little higher, so I'm going to jump up to the 8 and put a point, and that's going to be point B. For C, it tells me to run forward to the 5 and jump up to the 8. Put a point, label it C. With only 3 points, that tells me it is the polygon. I'm not finding a missing point. It says to connect them with the line. So once again, A connects to B, B connects to C, and since the polygon has to be closed in, C connects to A. I've got a triangle. All right, pretty easy. Find the area of the polygon, area triangle. So once again, I need a right angle, which I have, right? Because I have perpendicular lines. So I know that I have a base and a height there. I never use the diagonal, right? So I need to use my formula for area of a triangle. Now, some of you are going to have a little easier time if you imagine it flipped sideways, right? Kind of hard to flip your computer sideways, I understand, but you can flip your book sideways and see where that right angle is. Okay? So I find my length for my base, and I see that there are 3 units. So I have a measurement of 3. And then my height, I have 3 units, so another measurement of 3. So once again, to find area, I need to use my triangle's formula, base times height divided by 2. So that tells me I have a base and height, so I have 3 times 3 divided by 2. 3 times 3 is 9, and divided by 2, so 2 goes into 9 4 times, which is 8. Raise a decimal because can't have a fraction. I need a decimal here, right? So 9 minus 8 is 1. Add a decimal, add a 0, bring down the 0, and 2 goes into 10 5 times. So I end up with the area of this triangle, according to this graph, is 4.5 units squared. Don't forget on area, we have to square our label. So I know that was a really quick look with triangles and finding this kind of answer, but I want you to give this one a try. I'm pretty sure that everyone in our class can do this. If you get confused on it, then please come and ask and I'll help you. But go ahead and do as it says and find the area for this particular 3-sided polygon, and then come back and check your work and see how you did. So hopefully you have an answer, right? And hopefully you plotted it, because unlike a parallelogram, I can't just use the measurements that are given. So I had to go to 2 and 4, and that's going to be plotted with a point and labeled A. And then I have to go to 9, so forward 2 and up to 9, and that's going to be plotted with a point and labeled B. And then for C, it says to go 9, 9. So go forward 9, I'm running, and then I'm jumping up to the 9 and putting a point labeling it C. Now to create the polygon, now I have to connect them. And once again, we label them because I'm going to connect them in alphabetical order. So A goes to B, B goes to C, and C goes to A. So hopefully you got that far. Now for some of you, once again, the trick of turning your book sideways is going to help you see where the right angle is. And remember, it's the right angle that is going to indicate which is our base and our height. A to C is not going to be used because, once again, that is a hypotenuse that you will use in the Pythagorean theorem, and we don't do that in 6th grade, so we don't use the diagonal. So when I'm looking at the right angle, which is in the corner of B, then I know that AB line segment has to be my base. So hopefully, with the triangle, you counted those boxes in order to know what the base and what the height is. So if I go from B to C for my line segment, then I can count it and I see that my height is 7. My base going from A to B then is 5. So I have to do base times height divided by 2 for the area of a triangle. Therefore, 5 times 7 is 35. So I have 35 divided by 2. Now I'm going to put my numerator inside my division box and divide. And 2 goes into 3 one time. Minus 2 gives me 1 left over. Bring down my 5, and 2 will go into 15 7 times. Now, once again, I can't have a remainder, and I do have one. So I'm going to add a decimal point and then add a 0 and bring it down. 2 will go into 10 5 times. So we find out that with those 3 points in my triangle, my polygon, that I would have an area for that triangle of 17.5 or 17.5 square units. All right, so this one's going to be a lot of steps to it. I'm probably going to leave this question in our math class just to walk you through all the steps, but I want to have it on the video also so you can go back and review everything we had to do. There are many steps to this, and once again, if you're good little ants and you just follow the pattern, you're going to be just fine. If you try to skip around like the grasshoppers, you're going to end up in all sorts of different directions and forget important pieces. The first thing we want to do is we want to cube up the question. There's a lot of things to cube up in this question. The first thing I need to know is that 1 unit in this box is equal to 1 foot. Now notice the labels on this for my x-axis and my y-axis. All up until this point, we've had even steps or even increments when it comes to our x-axis and y-axis, increasing by 1. Well, my x-axis, now every line is worth 10, because counting by every 2 lines, I go 20, 40, 60, 80. On my y-axis, it doesn't follow the same pattern. Each line is represented by 2. So therefore, I'm going from 2 to 4. So every 2 lines, I'm increasing by 4. So I have to make sure that when I'm converting this and looking at all my steps, that I understand that it's the measurements that I'm looking at, and they're equal. 1 unit is equal to 1 foot, because that's going to be important at the end. So then I look at what my U is doing, and she is going to look at 2 different storage places that she can rent, right? And we're told that we have 2 different areas, a space A and a space B, that each charge a monthly rent. Each rent is a different amount. So therefore, if I look at space A, it charges an amount of $13.89 per square foot. Per means for every single square foot we have. Therefore, we have to understand that, once again, our units are not cubes or units. They are, each one is equal to a foot. Space B then tells me that I am going to be charged $13.49 per square foot. So I'm going to have to find the charge for a month's time for each of these units to figure out how to answer the question. And the question is simply, well, then which is the better buy, right? My U wants to pay the lower total monthly amount. Notice these boxed words. So I painted them a different color green because these are so important to be able to answer this question. In the past, many 6th graders with these type of questions would come and say, well, I don't know what I'm supposed to do because it doesn't tell me if I'm finding perimeter or area or anything else. Focus on the label, right? So when I see that I'm being charged per square foot, we know the square labels means we're finding area. So if it doesn't say, well, go through and find the area of the shapes, then look at the labels. And if it says that your labels are squared, you know you're finding the area. All right, so if I'm finding the area, then I'm going to start with shape A, because I want to figure out, is it A going to be the better value or B going to be the better value? So once again, as I'm looking at these 2 shapes, then I have to figure out what shapes I'm using in order to figure out what formulas to use. Well, my 2 shapes. So when I look at shape A, I can see that the bottom line is 3 cubes across, but the top line is only 2 cubes across. So if that's the case, then I know that these are not opposite sides are equal. So it's not a rectangle. It's not a rhombus. So this has to be a trapezoid. And then when I look at space B, well, that's a 3-sided shape. That's triangle. That one's the easy one. So what formulas do I use then? So in the back of your planner, in the back of your math book, in the notes for lesson 8.3, we have the formulas for area of a trapezoid. Once again, I prefer to use the A plus B, being the measurement of base A and the measurement of base B added together, instead of saying B1 plus B2. I find the students get very confused about B1 and B2 and what to do. So if I identify it as there's a base A and a base B, and it doesn't matter which is which, and I'm going to add those together, I find that 6th graders do much better being able to use this formula. So if I'm going to use that for my trapezoid for space A, well, then I remember that when triangles are used, then I have to use my base times height divided by 2. All right, so we're going to start with space A. It's a trapezoid, so I'm going to write my formula. Once again, be working little ants. Follow the steps, write the formula down, and then go through to find the numbers to plug into the formula and rebuild your math problem each time after you finish every step so you know exactly where you are going. Don't be a grasshopper and jump around and get yourself all confused. So if I need to find base A, now I personally prefer to make base A my shortest base on a trapezoid, but that's not required. You can do the bottom one, you can do the top, it doesn't matter. I like to do the shortest one. Excuse me. So when I look at it, I see the ordered pairs that are for those 2 points. So the ordered pairs are 8 and 14, 30 and 14. So when I'm looking at the distance across, once again, then I'm going to stack those ordered pairs, and the axis that is the same, I'm going to ignore that one. I'm going to subtract the 2 that are different. I'm going to put the 30, 14 on top because 30 is bigger than the 8. Then I'm going to put the ordered pair of 8, 14 down below. The 14s match up. It is the same axis, so I know I'm good to use this pairing. And so I'm just going to subtract to find the length. And 30 minus 8 is 22. So we're saying that the length of base A is 22 units, or in this case, 22 feet. Now I want to do the same thing, but now I want to find the second base. So now at the bottom, finding the second base, I see two sets of ordered pairs to find that shape, and I see 0, 0, and then the second point I see 30, 0. So I'm going to use both of those and stack them with the 30 on top because it's bigger than the 0. And I see that my y-axes are the same. They're both 0. I'm good to go with that pairing. So I'm just going to subtract the two that are different. 30 minus 0 is 30. So I know that base B's length is 30. So I have base A plus base B divided by 2. And now I have to do my height. And once again, my height has to be a right angle. And I can see that the right-hand side of this trapezoid in space A is a straight line perpendicular to the bottom of the grid. So that has to be my height. So when I look at those ordered pairs, I have 30, 14, and 30, 0. My x's are the same, so I'm good to use those. I just have to stack them with the 14 on top, the 0 on bottom, because 14 is bigger. I see that my x-axes now are the same, so I'm good to use those. I subtract the y's. So when I have 14 minus 0, I have 14. So we're finding that the height of this shape is 14 feet. Now I begin by doing the math. So I've plugged it into my formula. I see the equation I need to solve, and now I'm going to do the math, and I do the first step of addition. 22 plus 30 is 52. I rebuild my equation so I know and can see what my next step is. Now I have to do division because it's multiplication and division from left to right. I have to do 52 divided by 2. Well, 52 divided by 2, 2 goes into 4 2 times because 2 times 2 is 4. I have 1 left over. I bring down my 2 and 2 goes into 12 6 times because 6 times 2 is 12. When I know that my numerator is 26, now I'm going to say, well, I have 26, which is going to be my measurement times the height of 14. Multi-step multiplication. I start with the 4. 4 times 6 is 24. Carry my addition of 2. 4 times 2 is 8 plus 2 is 10. Now I go to my second number. Once again, I underline it and then I circle behind it because my second number tells me to bring down 1 0. There's one digit that's circled. I bring down 1 0. And then I have 1 times 26 and 1 times any number itself. So 1 times 26 is 26. Now I can add those together. And I get on my ones column, 4 and 0 is 4, 0 and 6 is 6, 1 and 2 is 3. So we're finding that the area of the trapezoid is 364. But that doesn't help me get to my answer of which is the better value, because better value talks about cost of money. So when I go back to my original word problem, I'm seeing that in space A, they're charging me $13.89 per square foot. And we know that we have 364 square feet. So now I got to do 3 steps of multiplication. So once again, starting with the 4. 4 times 9 is 36. Put down the 6, carry the addition of 3. 4 times 8 is 32, plus 3 is 35. Put down my 5 and carry my addition of 3. 4 times 3 is 12, plus 3 is 15. Down my 5 and carry my addition of 1. And 4 times 1 is 4, plus 1 is 5. So when I multiply by 5s, I get the 5,556. Now I go to my second number. Once again, I underline it. I circle whatever's behind it. So my second number tells me to bring down, how many did I circle? 1. I bring down 1 0. Now what I underlined is what I'm going to multiply with, and I'm going to ignore everything else. So I start with 6 times 9, and 6 times 9 is 70 or 54, excuse me. I put down my 4 and carry my addition of 5. 6 times 8 is 48, plus 5 is 53. Put down my 3, carry my addition of 5. 6 times 3 is 18, plus 5 is 23. I put down my 3, carry my addition of 2. And then 6 times 1 plus 3 gives me, or plus 2 gives me 8. Now I've got a third number, so I underline it and I circle whatever's behind it. So my third number tells me to bring down 2 zeros. And now I just multiply with my 3's, going back once again to the 9. So 3 times 9 is 27. So I put down my 7 and carry my addition of 2. 3 times 8 is 24 plus 2 is going to give me 26. Down my 6 and carry my addition of 2. 3 times 3 is 9 plus 2. Well, that's 11. Put down my 1, carry my addition of 1. And then 3 times 1 is 3 plus 1 is 4. Everything's nice and lined up. So now I'm going to add my products all together. I have 6 and zeros, so that's 6. And 4 and 5, that's 9. 7 and 3 is 10 plus 5 is 15. I carry my 1. 6, 3, and 1 make 10, and plus 5, that's 15. So I put down my 5 and carry my 1. 8 and 2 gives me 10. Put down my 0, carry my 1. And then 5 plus 1, or 4 plus 1 is 5. All right, so now I look back at my math problem and I remember that I multiplied a decimal number by a whole number. So I count my decimal spaces, and there are 2 of them. I'm going to move my decimal from right to left 2 times. So what we're finding is, with that area and that monthly charge, that space A is going to cost $5,055.96. That's a lot of work, but I'm only halfway done. Now I have to go to the triangle. All right, so when I go to the triangle, I'm going to go through the same process, but I have to use my formula for area of a triangle. I have to find the base and height and divide by 2. So when I look at the triangle, I focus in on the 2 points for the base. So my first point on the left is 30, 0, and my second one is 78, 0. So I'm going to stack those with the zeros matching up. Those are my y-axis, and 78 on top because it is larger. So focusing in on my x-axis, since my y's are the same, I simply subtract them. 78 minus 30 is 48. So I know my base for the triangle is 48. So I'm going to plug that into my formula and then find my height. Notice that my height is the exact same side as the height of the trapezoid. So it's going to be the exact same math. I'm going to use and focus in on the 30, 14 and the 30, 0. Remember that I have to have a right angle in order for it to be the height. And this is drawn as right angle, so that corner is definitely going to be my right angle. Therefore, that's my base and my height. And that diagonal side, once again, I get rid of it. I'm not going to use it. So when I stack them with the 30, 14 on top, and I put the 30, 0 underneath, I see my 30s are the same, so I'm good with that pairing, and I simply subtract the y-axis. 14 minus 0 is 14. So I have the same height as I did with my other shape. So I end up with base times height, 48 times 14, divided by 2. Well, before I can divide by 2, I have to multiply the 48 and the 14. All right, so I do my multiplication starting with my 4. 4 times 8 is 32. Put down my 2, carry my addition of 3. 4 times 4 is 16, plus 3 is going to give me 19. My second number tells me to bring down a 0. And just like before, when I multiply 1 by something, it's just going to be that something. So 1 times 48 is 48. I add my products together. I have 2 and 0, which is 2. 9 and 8, which is 17. Put down my 7, carry my addition of 1. 4 plus 1 plus 1, that gives me 6. So we're finding that the area is, or when I multiply to find the area, I get 672. And that would only work if that was a quadrilateral. And since it's a triangle, I found my numerator. So now if I rewrite my equation, I see that I have 672 over 2, so I know I have to divide. 672 divided by 2, 2 goes into 6 3 times, because 3 times 2 is 6. I don't have remainder, so I bring down my 7, and 2 goes into 7 3 times. Well, 3 times 2 once again is 6. I get a remainder of 1 this time. I bring down my 2, and 2 goes into 12 6 times. So I find that my area of the triangle is 336. Well, now, in order to figure out how much I'm going to be charged for a month, if I get the triangle, then I have to look at how much we're charging for that space B. And that's $13.49. So now I got to go through the multiplication. It's a lot of work on this math problem, but follow it step by step and you're going to be okay. I start with the 6, and 6 times 9 is 54. I put down my 4 and carry my addition of 5. 6 times 4 is 24 plus 5. Well, that's 29. Put down my 9, carry my addition of 2. 3 times 6, that's 18, plus 2 is 20. Put down my 0, carry my addition of 2. And then 6 times 1 is 6 plus 2. That gives me 8. So I go to my second number. That tells me to bring down 1 0. I'm going to multiply with 3. So now I do 3 times 9. Well, that's 27. Put down my 7, carry my addition of 2. 3 times 4 is 12 plus 2 is 14. Put down my 4, carry my addition of 1. 3 times 3 is 9, plus 1 is 10. Put down my 0, carry my addition of 1. And then 3 times 1 is 3 plus 1, and that's 4. Now I have a third number. I underline it, and it tells me to bring down 2 zeros. But notice that I'm multiplying by 3 again. Well, that's going to be pretty easy, because if I had 4047 before, I'm going to have 4047 again. So I can write down those numbers and be confident that the answers are going to be correct. That allows me to add them. So on my far right-hand side, I have 400, which is 4. 9 and 7 is 16. Put down my 6, carry my addition of 1. 7 and 1 is 8, plus 4 is 12. Put down my 2, carry my addition of 1. 8 and 1 is 9, plus 4. Well, that's 13. Put down my 3, carry my addition of 1. 4 plus 1 is 5. And then I have a 4. A lot of work. So multiplying by decimals, there are 2 decimal spaces, which means I have to move my decimal point from right to left. So when I look at space B, then I see that per month I'm being charged $4,532.64. So now the question once again is, which location should she choose if she wants to pay the lowest amount? And the answer, with all of that work and like 25 minutes of work, is simply B. B is the choice. All right, so I know that's a lot of steps, right? So I want you to practice. I want you to be able to watch this video as many times as you need to. I want to give you all of tomorrow, other than maybe about 10 minutes where I'm going to work through one more problem with you on a video to review this, to do the questions and ask me for help, because I'm here to help. All right, so good luck.